little bit later, so we might have a little bit of a hiccup while I flip windows. But I wanted to share this one here. Um, so I'm going to introduce myself just a little bit before I talk, so you kind of know where I'm coming from and where my opinions are based and coming from. I kind of develop in everything. My first love is probably Java because that's the language that I started with more or less in early versions of Java, like 1.1, 1.2. And I've been programming for around 25 years, and kind of run the gamut between a first or third level support programming, technical lead, now an architect. I've worked for probably most of you will know recognize most of the names on that list there. That's not the exhaustive list. I've kind of been a little bit of a rolling stone in parts of my career or during times of my career. Magnum Technologies was bought by EMC, which was then bought by Dell Computing. And Magnum Technologies did some really neat things on understanding and polling CPU utilization, disk utilization on Unix machines, on big old Unix machines. And so at one time, I had to understand and learn a lot about systems. And so Linux is still a hobby of mine. The Unix world is still kind of a hobby of mine a little bit. I do understand a little bit more about systems than the average developer, I would say. So because of what I had to learn while I was writing software that basically worked with systems. And that's transformed now into cloud development. And so I spend most of my time being an infrastructure architect on AWS because I worked for AWS Professional Services for a period of time as an infrastructure and DevOps architect. So I understand the DevOps space and DevOps world. I'm an author of 2 books. You can go out to Amazon and find my books on regular expressions. I don't think that they're not as amazing as the O'Reilly book that was kind of the I would say the authoritative book on regular expressions, but mine were meant to be accessible towards people that don't want to really dig into the details of how a regular expression engine works, but instead is like, I just want one to know what an email address kind of looks like, or a phone number or whatever. And those are the 2 books that I've written. I've co-written 3 others. They're well out of date. 2 of them on PHP, and I don't even know that PHP is one of the top 3 or 4 languages anymore. It used to be a lot more common than what it is now. And one of my books that I co-authored was on Red Hat Enterprise Linux. I had written the security and the Windows chapter, the Red Hat for Windows administrators chapters in that book, among a couple others. I used to write quite a bit for IBM Developer Works. If you look, you can find some of my articles still out in the world, but most of them have been archived by now because that was pretty early on in my career. But there you go. I'm obsessed with OO patterns, enterprise integration patterns, and then you can see build process and code quality, which is one of the reasons I've loved being a tech lead. I try to teach. I've always come at a perspective of when I see code that maybe could be improved for some reason, to try to take that as a teaching opportunity and talk about it that way. I started back before I want to get into this, but before tools were popular, you would read books, Code Complete, Rapid Development. These were books that you would read to understand some of the best practices for coding, and code reviews were about people that had read the books, and then they would review your code and try to give you pointers and so on and so forth. I'm glad to know that everybody here is not an expert in AI and ML. I'm not, and so I would be out of my depth pretty quickly in an expert conversation. I'm an enthusiast. I'm one of those people that is so excited right now about where we are in the industry and kind of a perfect storm that's coming. And this is what we're going to talk about towards the end of the presentation tonight. All of the things that have been happening in this industry that really set a very good groundwork and set an exciting stage for having AI and machine learning help us get better at security and programming. Hobbies are cycling in Linux. And so, Eric mentioned my cycling trip. This is the first 25-day one that I've taken. It was the first over 1,000 miles that I'd gone, and it was just a wonderful time. I took a couple Kindle books with me, or I took a couple books on my Kindle with me. I had meant to kind of read some trade, books. I brought domain-driven design and actually a few security books, and then I ended up just really auguring into science fiction while I was there. And I love sci-fi too, so that's good. I always say, and I always have a takeaway at the bottom of my slides. What an exciting time to be in the industry. I think I say that every single year. I probably said that 10 years ago. There's no better time than now to be in the industry. And now I'm saying it. I just find myself as saying it over and over and over again, which is why I think I still love being in the industry that we're at. So as a means of introduction of what we're going to talk about tonight, or what I'm going to show you, I'm going to give you a history of code quality and quality tooling, a short history of an automated build and how build processes have changed over time. That's pretty important when it comes down to how the tooling is used. The advent of infrastructure as code is super important. When we're talking about how we can use the code quality tools, and now we can apply that to infrastructure, that becomes something that's really, really pretty powerful. We have open source. Open source has been around for a long time, as we know. GitHub is not the first open source repository, but GitHub by far is the 800-pound gorilla of the open source software world, and that has enabled some pretty exciting things. We'll talk about that. I'm going to do a short demonstration of AWS CodeGuru. So if you are looking tonight for like an hour-long deep dive into AWS CodeGuru, not necessarily what we're going to do tonight. I hope people aren't going to be hanging up. But we're going to talk briefly about how AWS CodeGuru works. I'm going to show some screenshots and show a little demo of my experience with it so far, and then use that as a springboard to talk about some other AL and ML AI opportunities in this space. And I hope that becomes kind of an exciting conversation that people might feel engaged with. So goals for tonight are to learn. For some of us, it's going to be about reminiscing. Those of us that have been there and done that with the static code tools and so on and so forth, and then get excited about what the future looks like in this space. So I know that this is out of order a little bit, because as I was putting this together, I thought, oh boy, before I talk about tooling, I'm going to have to talk about building. And so we've always had some sort of manual process. And I said, in the 1970s here, Make came out. And so Make was the tool that you'd have a Make file, and it would basically lay out all the steps that you would have to build whatever your software is. And you could do some pretty complex things with the Make process. Before the 2000s, I had in that Unix company that I was telling you about, we had cross compilers happening between machines, building the binaries for each one of the Unixes, and building the binaries for Linux and so on. Believe it or not, we had a chatbot set up, and we could kick off the Make process with a chat command. Now I would be horrified from a security perspective, because we actually had this, like the chatbot was kind of open to the internet, so to speak, and so we had security by obscurity, which is a horrible means of securing something. But we had that type of complex system, and that type of complex system at that time kind of stayed with me. And so I used tools like Ant very early on, tools like Maven very early on. So like in the early 2000s, I'm going to stop just for a second and say that, if there are people here watching this that want to, in your mind, chase me around about Fortran or RPG or other languages or technologies that probably fairly did have these processes earlier on, that's fair. This talk is really intended to technologies that are kind of still in use, so to speak, and still relevant kind of in this modern distributed and cloud world. And so I'll take a step back into this. Language specific build tools, like, so Ant was released around that early 2000. Maven was released in that early 2000, and Ants and Maven's goals both were be to a system like Make, but to be cross-platform so that I can kind of use it wherever. And so I was building personally Java applications automatically, and then had scripted hooks so that you would check code in to CVS, I think it was at the time. So this is even before Subversion, even before TFS and whatnot. But using tools like that, so then as the code changed, we would build it right away. And we were always in kind of a state of having the binaries be good to go before the terms continuous integration were coined, or continuous building were coined in the way that they are today, and the way that people understand them today. We weren't the only ones, I'm sure. But again, this has always excited me. Then after this, the language specific tools came out. Some pretty interesting tools started coming out that were like build systems that would maintain this. So usually if we're in a group, I would ask by show of hands, who remembers cruise control, which would be the first one. I think that ThoughtWorks came out with cruise control, and I'd use cruise control. So these are ones that possibly Des Moines used cruise control earlier. Yeah, that is one of the tools that I use. Hudson Jenkins. So before Jenkins was Jenkins, it was Hudson. And so some of these automation tools just kept getting better and better. And so that you had this mindset, whereas when this code changes, I want to build the code and make sure that the code compiles successfully. It wasn't long before tools got involved in that, which we'll talk about in just a second. This is why it's important to talk about it now. And then in the 2010s-ish, probably a little bit before, it's like, okay, now we do it continuously. Now we're doing it several times a day. We're doing it whenever the repository changes. We have different builds between kind of like an integrated build, a build that might test performance, and so on. And it just kept evolving from there. In the late 2010s, we're talking about deploying continuously. And so if I go back, and I know by how old my kids are because of where I was in my career, like how long I was doing some of this stuff. And Travelers Insurance, we were delivering continuously. I had written or worked on a system where as soon as code would change, it would build an MSI basically and store the MSI in a location where it could be pulled in by a server admin and installed. That's continuous deployment or continuous delivery rather than continuous deployment. And then it just, like I said, it just keeps getting, we keep going farther on. And it really was infrastructure as code, which we'll talk about later, that really enabled continuous deployment. And the funny thing is, I found myself within the last year between Go and Python and some other things writing makefiles again. And so it's kind of fun how it goes kind of full circle. I just thought that was amusing, so I included it there. Again, infrastructure as code being a key enabler with that continuous deployment and delivery. So a short history on code quality tooling. Like I said earlier, it was back before the tooling was as good as it is now. A lot of code reviewing may have happened from people that were kind of opinionated or obsessed about how code should look. They may have read books like Code Complete, The Pragmatic Programmer, Clean Code, maybe even. And then I've got these links, by the way, at the end of these slides to these books, and understood. Okay, as an example, I can't remember exactly which book, but it's a concept that as your functions get longer than a screen, right, your bugs in said functions begin to really creep up, really begin to go up, actually at an exponential rate, depending how long it is, because it's more that you can see and understand at one time. And so there's validity behind some of these rules that are saying, don't make methods too long. One of the things that I didn't put on the slide here was there were tools that look at cyclomatic complexity, which is looking through the different paths that the code can take. and understanding how many paths do you have possible. And if it gets beyond a certain threshold that's settable, uh, you can you tell it to flag the code. You have to go back through and kind of simplify the code base. And I've got CPD here. So that's copy and paste detection. And so we'll talk about that. I've got a slide later on that. And dependency analysis. All of these tools are best integrated with one of the build processes that I talked about earlier. So if you're not gating your builds now, you should. And most projects now do. It's become way more of a common practice. Back when I did it to start out with, it was kind of almost considered draconian. It was considered like, wow, very strict. But to have the code say, okay, I've crossed these thresholds where enough errors have been found in the static code analysis, or I've found enough copy and paste problems, or my dependency analysis has given me some grief. I'm going to stop the build here, and I'm not going to proceed any further. And so, when in a mature process, that means that you can't even deploy with these mistakes, which is really where you want to get to, especially as we look further on down the pipeline at the infrastructure as code. And so if you can imagine that I can't even get out in the world, it's really what enables you to be able to deploy continuously with confidence. Otherwise, you don't know if you're breaking things. Even if you have unit tests in unit test coverage, there are things that static code analysis will catch when it comes to the quality of your code. That is not necessarily caught by unit test coverage. I say to people that I work with on development staffs that it's so, because people love to write standards for whatever reason, or I've run into people who like to write standards. Maybe we should have some standards on this. And I say, if it's a rule worth having and a rule worth documenting, it's now, in this day and age, because it's so easy, a rule worth automating. So what is static code analysis? I talked about it being a tool, and really just briefly, you've got predefined rules. In the Java world, as an example, I talk about PMD here. I'm going to flip back, but these tools have their own predefined rules for that language. The tooling is pretty darn mature in most of these language, and if in a good or much, I would even say mature workflow, I would argue for that. In a mature workflow, you have the build process and the IDE asserting the same rules, essentially. Your idea is to shift things as far left as possible to close the feedback loop for the developer. And then that means that as you're closing the feedback loop, you want basically the minute they're typing code, it's a squiggly underline, and it's above and beyond maybe what the default rules might be for the IDE, because most IDEs that I've worked with recently have some sort of default policies for this. So many of them support writing custom rules. I, in the past, try to steer clear of that. In recent past, I should say, far past, used to write custom rules all the time. Because we would, again, if somebody wants to document something and if it's important. So as an example, back in the Java world, we really cared where I was at the time, how our packages were named. They wanted to be COM, they wanted to have the company name, they wanted to have the division name, and so on. So we wrote custom rules that would actually look and make sure that your package name is constructed correctly. Most of these rules, by the way, use pretty simple, like that one uses pretty simple pattern matching. It's not an AI rule. It's not even really like following code structure or anything like that. It's just doing simple pattern matching. Problem there is that somebody needs to define the rules. So I don't know if it's age that's got me a little lazier, or maybe I've understood that some rules really don't matter, even though that they appear that they do. And so really what I try to do is I try now to default to whatever the industry standard or common rules are, if there are. Python and Go, by the way, are two languages that have really good. I wouldn't say that I agree with the rules, that not that being good, but they've got pretty prescriptive industry rules around. So I've got some examples here. If other people on the call have used these rules, they probably, or use these tools, they probably recognize some of these rules or some of these tools. So we've got Java, we got PMD and find bugs and spot bugs. And in your build process, whether you use Jenkins or Hudson or Drone or whatever, you've got means of running these rules and then failing the build if they pass a certain threshold. You can treat the errors as warnings or whatever you want to do in order to make that happen. Pylint is an example for Python, StyleCop for C#. This is not an exhaustive list, and there are definitely ones here that aren't on here, but I tried to get the ones that are probably the mainstream ubiquitous ones in that space. And then for Go, these are languages that I've programmed in most recently. I know that I left JavaScript off of here and a couple other languages that you're probably thinking of. So I'm going to go on then to just copy and paste detection, talk about that really quick.
Nathan, there's a question in the chat.
Oh,
yeah.
I don't even have that on.
I'm keeping a look at that. So do you have a rule generator in your AI system?
Oh, when we talk about code, when we talk about CodeGuru, which is the example that I have for the AI rules, I want to talk about how they're harvesting rules, how they say they are. And I think that that's going to be how, I think that we're in this transition where the static code, this is kind of what has been. Someone had to take the time to go and define these. But I think that we can be a lot smarter about how we define these rules and harvest them. And so I'll talk about that a little bit. And I think that I think that's a great point. For copy and paste detection, that's not using. It's using an algorithm there that there's a Wikipedia article on if you want to really understand, if you don't know it already and want to understand more. That encourages the don't repeat yourself, DRY. I've been most shocked, I think, turning this on in my own code bases that didn't have it on prior. Find how many times you've cut and pasted code or copied and pasted code, and really gives you an opportunity to be able to select some things in order for and build libraries for reuse and so on and so forth. And then really quick dependency analysis. Now this is where we start to get into some really clever automation, right? And so dependency analysis specifically in security, because if you think about how it used to work when you had especially open source libraries that you depended on, you kind of pull them in by hand. And this is before package management really became a thing. And so Maven, when it came out for Java, and you're managing dependencies with Maven dependencies, and then NPM is example for Node. Go has its own package management, pip and poet for Python, and so on. And so dependency analysis tools will look at, are there known, and then of course there are commercial ones and open source for this, right? But they'll look at, are there known issues with this library? And if there are, GitHub's dependabot, I've got an example here where it tells you, hey, this dependency's got an issue with it, and it'll actually even create a pull request for you and bump the dependency to the version that is okay. The number of dependencies and conflicts between dependencies is a little bit more advanced, but I think that there's some area there to also improve. As we're looking at using AI for this. So I'm going to keep going. So that was a kind of a really quick rundown on static code analysis tools and how they've changed. Does anybody Yeah, I'm trying to understand like the age and the breadth of experience, and age is actually a bad metric. I'm sorry about that, but the breadth of experience with our audience to see, what type of tools people have used and are familiar with. So, are there? I'll stop here. Are there any questions about like how or why, or comments, thoughts, bad stories? I'm trying to pull a chat here. There we go.
Do you see it? So there's
Oh yeah. I will
okay,
share slides later. Yeah,
awesome.
yeah,
Thank you.
yeah. And that's probably a good thing because I've got some extended notes in my slides too, so that may be helpful. Um, okay, great. I have uh, some prehistory with infrastructure as code, and so again, I'm kind of I started out with this called infrastructure as code before shell scripting, and I think those of us that those of us have remembered, that have had worked on old Unix systems in the 90s and prior, probably remember doing a lot of Perl, a lot of shell scripting, a lot of scripting in order to in order to do stuff. We would mount mount NFS directories to certain configuration directories like the etc directory and NIS and so on and so forth. And that's how we would do like configuration group management across a lot of different Unix machines. Um, I didn't realize I'm wearing a Puppet T-shirt, but I didn't realize that Puppet until I was kind of going through them, trying to put them in timeline. I had Puppet actually farther on down the line. I didn't know that it was first came out in 2005. I was surprised by that, honestly. I'd used Chef first personally, so I really began to like these kind of um, um, declaration-based configuration management tools, these automated tooling like Chef, Puppet. I mentioned Ansible, and again, not an exhaustive list. There are many others. I didn't have Chocolatey here as an example for Windows, or desired state configuration for Windows. But these are tools where you've got a declaration file, or you've got a file that says, I've got a user and the user is named thusly. I've got a directory and the directory is named thusly, and file it. And then the tool reads this file and does whatever it needs to do in order to make that be true, right? And so this really started to enable a lot of fast system building that really wasn't, I mean, prior to this was kind of a, these were manual processes. If you needed a server configured or something like that, it wasn't something that you could just have happen in 15 minutes like it is now today, or maybe an hour in a really extended build now. It took a long time, and that was just kind of the way things were. This type of automation then all of a sudden starts to set the stage for things like auto scaling in a cloud world, right? And a lot of automatic infrastructure provisioning and a lot of really interesting like ephemeral instances and things like that that weren't available before when all of this required manual intervention. Now, I think that infrastructure as code, I mean, if you look at it, it's kind of new, and there's a lot of migration activity I know that happens. I worked for a consulting company for a little while and did a lot of migration uh, uh, design, if you will. We've got an old J2EE server that's running a bunch of apps. How do we get this into the cloud, and how do we automate the build out of this app server that wasn't automated before? And so that modernization is something that I've talked about. And I think that a lot of people are probably kind of in that, if you were to draw a graph or whatever, I think a lot of people are in that part of the curve where modernization is really taking on the main thinking. And so they're not yet at a point where it's basically like right now we just need to get the files written. We just need to do the work. And what we haven't come down to yet is taking the discipline that we've gotten from static code analysis and all of the different tooling that we've had for application code for around at least a decade longer, and to use those same disciplines in the infrastructure world. Now, it could also be that just because the development world and the infrastructure world are two different worlds, and there aren't actually before DevOps was a coin term, there weren't a ton of people that crossed into both. So most people were either an operations engineer or developer, and it's a great thing. But I think that some of the development disciplines, like that static code analysis, even the copy paste detection, all those things like that, aren't, from my experience and from what I've seen so far, aren't as in a prevalent use in the infrastructure as code world as they were. Case in point, my bottom takeaway there. There's a security cloud threat report, I believe it was done 2020 to 2019, that listed over 200,000 security vulnerabilities, just some cloud templates that they had reviewed. I don't think, I can't remember, I'm going to just go ahead and talk about it here. It might be a teaser, but we all have seen, unfortunately, data that's leaked accidentally by misconfigured blob storage, and we've seen those headlines, right? Especially if we're interested in the security space. And so that it still happens, and that we don't have tools that are as prevalent as Dependabot is in GitHub and some of these other static code analysis tools that are in wide use. That's a concern to me, and I think that that's where one of the things where it's exciting, because we have opportunity to improve and to be better. Okay. So OSS and GitHub, and then this is where, like I said, I start talking about the perfect storm. This is a history lesson up to this point, and now we're talking about how the world has changed, and not just, I mentioned here at the bottom, compute as a commodity now, right? Which wasn't the case before. Compute's always not been as cheap as it is now, and it's not been as scalable or elastic as it is now. And so that's enabling a lot of things, obviously, in the processing space. But I would argue that the amount of data that we have available to us, I've been always told by practitioners that the more data you have, the better your models are, and so on and so forth, and the more that you can learn, and the better that you can learn. It's not unlike our learning. And right now in GitHub, so I was looking for some statistics, and GitHub now lists on their page that they got 65 million plus developers in 200 million plus repositories, and in 2020 they had 1.9 billion code contributions. So let that sink in for just a second. Think about the amount of data that we have available to us as an industry about how code changes and so on and so forth. Because not only do you get the code contributions, but you've got some interesting process in there, because you've got people that upvote, downvote code contributions. And this is kind of important because AWS CodeGuru says that it uses these contributions and improvement in code to be able to basically do rule harvesting, which I'll get into in just a second here. So again, think of all the PRs that have been made and approved, rejected. Things have gotten better. All the code that's available to us, and so on and so forth. Does anybody remember Clippy? So think of how advanced we can make Clippy. I didn't mean to bring up any nightmarish, because people have pretty bad memories of Clippy in Microsoft Word. So Amazon CodeGuru, and this is where I'm gonna bump for just a second here. I hope that this is not too rough. I'm going to flip my my display maybe a little bit, or maybe I can just open up the maybe just open up my browser here. I wanted to show you all a little bit about what it looks like here. And so everybody see my browser here? Okay, fantastic. I got the thumbs up. And so I've added in some repositories here. And I should note that I put in, I had Pylint and PMD both running, Pylint running on my Python and PMD running on my Java, just to see what's the difference. Now the Pylint and CodeGuru ones matched up interestingly pretty well. PMD found so PMD, and I didn't really dig into this. I didn't want to have this be a super exhaustive thing, but PMD puts on their website like what, and that stands for Program Mistake Detector. PMD does a lot of stylistic things, just like Pylint does as well. And so what I didn't in my CodeGuru findings, which I'll show here, that didn't pick up on some of the stylistic things. Now, as a developer who's gone through different languages, I like to crank those on to whatever the industry standard is. So Pylint I run because I want to develop Python code like a Python developer. I want to write Java code like a Java developer, and so on. And without the tools keeping me honest when it comes to, well, in this language over here, constants are uppercase and lowercase, and here, underscores are preferred, and in this language over here, underscores are really uncool. I want to know that, because I don't want people to look at my code and go, golly, this is Python, but obviously a Java programmer has written this. Especially if everything ends in factory. That's an OO joke that's probably not that funny. Sorry, but it's true. So I'll show you how this is integrated with the GitHub pull request process, which is pretty cool. It suggests improvements in your code, as you can see there. And then any of these tools, most of these tools provide relative links, especially the web-based ones. You can click on a link and it'll tell you what the best practice and so on and so forth. I always think that the ones that don't are kind of a pain. They'll give you some kind of one number, and then you got to Google it and find out what it is, and so on. But I had the verbiage up here on their website, and from their FAQ, and I'll from what they talk about in their code harvesting. And so through only their Amazon, so it's not just the Amazon code bases, but they basically go through and look at the code bases, but also look at the code changes that are intended to improve the quality of the code. And then it also pulls in, so CodeGuru is capable of pulling in the documentation data. And so what they do is they harvest rules. And so this is a strength, in my view, or maybe it's a good complement, maybe not an outright replacement, just depending on what your goals and objectives are. But this is a strength because some of our problems may stem from people not defining the rules quickly enough. And if you're waiting for someone else to define the rules, or if you're using default rule sets and so on and so forth, and just kind of relying on the code to keep up, this is exciting, because if you can start learning as industry code changes or code improvements are made, chances are you can harvest these rules out ahead of time. There's a question. I don't know what CodeGuru does. So CodeGuru, so think of those static code analysis tools that I showed earlier. CodeGuru is an AI-based, from AWS, an AI-based code analysis tool. So it's not static. It's learning over time, and it's taking a look at the quality of your code. And I'm going to show you some actual, results in my console in just a second here. So there's security. There's a security aspect for that code review too, and you'll actually see some of my security findings, which is exciting. I I don't mind showing those to the world, I guess, because I'll fix them. All right, so I set up a couple repositories, and to do that, they have a fairly simple wizard that you can fall through to create a code repository. I'm going to go ahead and just show you that it does support. Wait. I want to actually show the repositories this way, and say associate repository, so I can see that I've got a GitHub account. I can of course connect to Code Commit and Bitbucket and GitHub Enterprise Server right now. That's what they support. And so when I had connected, clicked on this connection for GitHub and connected to this GitHub account, it then showed me all of the repositories that I had, and I could add that repository to this system. And then once the repository was added, so this is my own repository, I can go through and I can add a code review. So what I did is I requested a full repository analysis, like one time. And I said, could you just analyze my repository and tell me what you find? The Python one was pretty interesting. So I written I call it anonymize. I had a use case where I had a big file full of email addresses that needed to be redacted before we could pass the information on to somebody else. And so what I had done was written a script. There may be some industry tools, but I'm not. Data is by, working with this type of stuff is one of my blind spots or weak spots. So I wrote a tool that could go through and substitute all the email addresses with generated ones. I would just give it gave it lists of names, and it would just put the names together and generate it. The one thing that we had as a requirement though is that it knew that if it replaced nathan.a.good at gmail.com one time, it had to do it with the same address each time, because I wanted to keep the frequency that people showed up in the file the same, because it mattered in our system when it came to how that worked. So anyway, I wrote this system and I wrote this really simple script. And here it'll show me on line 19. This is actually a security problem that I need to use a different, they give you the link. I should slow down a little bit. I'm sorry, I'm screen sharing and it's going to take a second to catch up. But it provides me a link to the PEP documentation of why I want to do things the way that I want to do. And so it found this one time in this analysis. If I go back to the other code reviews really quick, I'm going to wait for just a second. This recommendation here. So at one time, I was a maintainer for the Jenkins CloudFormation plugin. So I'm not it was 6 years ago. I can't believe it's been that long. But this here, I'm sorry about that. I meant to click there. Has given me some findings based on like the blog articles and best practices for keeping keys managed. If I look more, client constructors are now deprecated in favor of using builders. So if I learn more here, I see right here, client constructors now deprecated. And they've got examples of what it used to look like and what it looks like today. And so as you can see here, I can do this one time, which is exciting. But what's really also exciting for me is also a user of GitHub is once this has been once this repository has been linked, as I create pull requests, this is now tied into that process, and CodeGuru will look at the pull request that I create and will make comments in line in the pull request, which is pretty exciting. So if I look here at this, it tells me that, hey, you didn't need to use this sub because you aren't using any variables, which makes sense. Not only can you train it here, which it learns as it goes. So you can say, was it helpful or was it not? And so if you think of it, I'm basically training the model, right? At this point. Sneaky. No, it's not really that sneaky. But I mean, I can say if it's helpful or not, and so good suggestion or not. But the other thing that I think is pretty darn powerful is that within the actual pull request itself, so here's the line, within the actual pull request itself, it's closed already, so I'll bring it up here and I'll slow down so it catches up. But I've got the pull request and it says, it right here, this recommendation has been generated by AWS or Amazon CodeGuru reviewer. I can vote on it right here too with an emoticon. So I'm also training the model, and so I can see, was this a useful suggestion or not, and so on. So the idea of this being, it'll get smarter over time, not just me using it, but everyone else using it as well. And if I look at this back in the day where you're sitting there editing an XML file with a regular expression, it's kind of like light years ahead. I don't know that I would have imagined something like this 15 years ago when I was writing some of those rules. That we could just say, hey, I've seen this change, or here's a suggestion. Is it a good suggestion or not? And then over time, it'll either suggest it or, not. So any questions? Did that answer the question on what CodeGuru is? It was more than a sentence. Awesome. All right. Okay. So this is what that was it is in terms of CodeGuru. That was my one example. The thing that I want to talk about is the opportunities that we have with this same. By the way, Java and Python are supported today. If I know Amazon as well as I do, they'll improve upon that and add languages as they go. But Python and Java are the ones with the languages that are supported. And those are the examples that I showed earlier. So right now, all of the infrastructure as code tools that I've seen are like the static code analysis tools. They're still kind of in that older state of static code analysis, if you will, right? That's a great question. What would you change about CodeGuru? The first thing I would do is I would have it do infrastructure. The current slide right now, infrastructure as code, like right now, right away. And not just like you're linting in CloudFormation. You've got a linter in CloudFormation that tells you, variable names need to be only alphanumeric. This needs to be an integer versus a string, or a string versus an integer. Those are the tools that are available today. What I'd really like to see is suggesting architectural improvements. We should have an AI-based system that is aware of looking at security articles to say S3 buckets. S3 buckets have been a problem in that people have misconfigured them in the past and accidentally leaked data. So how can we have a tool basically that's watching the security bulletins, watching the best practice documentation, consuming those things, and then suggesting improvements for us on how to build our infrastructure better when we code it out. Oh yeah. There's a question there, but it is a static code analysis tool in that sense that it doesn't test your code. So they have a profiler, but it doesn't. Yeah, it won't write automated unit tests for us. That was a question that came up. which is a whole other conversation. You can almost have a thing on, why isn't AI right now writing our unit tests for us? It can look at the code, understand the inputs and outputs. Why do we even have to write a JUnit test anymore today in this day and age? But so it's an exciting time about infrastructure as code. I think this is a golden opportunity for us to get a lot better at this is a lot better at being able to understand how we can build secure infrastructure. There are tools in the market today. So I mentioned Checkov there, that's got 1,000 policies plus policies. And so like if I build an unencrypted something or other that could be or should be encrypted, it'll flag that, right? But again, we're still talking about a static tool here in that, or a static tool that requires people to define the rules, policy as code, ahead of time. And this is where I think that we can use AI to improve this process. Secure architectural improvements, right? We know we know that there is pretty prescriptive advice from our different cloud vendors. And AWS, just for an example, they've got the well-architected framework. That well-architected framework will kind of tell you, do you have auto scaling turned on? Do you have, and right now it's manual process to go through that. Think of the power of having AI be able to look at that infrastructure and suggest, based on what your code looks like, how you could make it more efficient, cheaper, operate better, how to make it more secure. Basically, check off all of those ilities in that talk that Eric saw me give earlier. So that's it for me right now today. That's what I've had. I would love to talk about this more. So if anybody's got some thoughts, that would be outstanding. I will share these slides. I do have a reference slide after this one that's got some links to the different books, the different links for tools, and also a link to AWS CodeGuru's facts and so on. So yeah, if you'll see, there was a question there, self-aware AI to start, or self-aware AI code. I think I had one of the original takeaways that I had, and then I thought maybe it was a little bit too snarky, as I said, finding a way to get us out of our job, basically to replace ourselves.
Yes.
with AI. Oh, and what do you think software development would look like in 5 years? Here's what I think that's something that's super interesting. There's probably a couple of us here that remember and are probably pretty horrified when there was a movement from, I want to say, a good 5 years, where they were really trying to, different companies like Rational were really kind of trying to do this like visual coding, right? You would right click and you'd have a car object, and you would add all the methods in and so on and so forth. And round trip visual coding and round trip engineering was like something that was really, I think, tried and really never, we don't do it today. So it obviously didn't really take off. I think at some point, AI is going to, and just the sheer amount of code that we have available at our fingertips as example, is going to make something like that a lot more realistic. And I see us doing a lot more like, there's a game that my son took to learn how to code with zombies and plants, and now I don't remember the name of it. But it was moving around little blocks, and the blocks would they would represent if-then statements and so on, right? And it was really about moving, and it was a brilliant way to teach programming because it was about thinking through the algorithm and not being concerned about the syntax and the essentials of the language or whatever. And I'm excited that something like that, I think, is going to end up taking off, but it's not going to be a game anymore. It's going to be basically like us programming. We're going to have little blocks that we could drag and drop and say, if this and if this and if this, and we might not really care if it's Java being generated in the background Python or whatever, or maybe nothing's generated in the background. Maybe it goes straight to bytecode. That's what I think would be pretty exciting. And no, I have not tried hypothesis. That's a new one on me. So thank you for that. I'll have to check it out.
Okay. Yeah. Questions, comments? So Nathan, I am a mechanical engineer, so I am in the curious crowd. So
All
this
right.
is all super interesting for me, yeah. But I can see how, like, in my day job, how AI would be useful. So, you know, not along the lines of your topic today, but just, you know, discovering molecules perhaps to make a better adhesive, just iterating virtually to get to a chemistry that we could try, we could prototype with physically. Yeah. you know, so Takia really is, you'd think that's like a layman's language, but really that's how chemists talk about adhesives, so the thing that gives you tack is called a tackifier. So how much you add in a chemistry, gives you some properties that you want, while it detracts from other properties that you also want. So so I always think that's funny when people say tachia, thinking that's layman, but actually it is words we use in chemistry.
There's a There was another question on what do I think is the bottleneck today in software development lifecycle? I think the bottleneck a lot of times now is being able to back before you were even constantly going out to the cloud as an example, as an automated infrastructure, and even now it takes some time. And so before that, when you were just building an MSI or building an RPM file or something like that, so you're doing continuous delivery, that was pretty fast because unit tests are pretty quick in their execution time. And so in my experience, when I play the role of being an infrastructure engineer, and I'm writing Ansible, or I'm doing all that, takes some time to test. I haven't found consistently good testing frameworks for infrastructure as code. Linting certainly exists, but real testing frameworks, and so that's my bottleneck. Personally, is whenever I want to when I want to cross that line from delivery to deployment, and I'm actually testing deployments, that seems to eat up a lot of my day. I don't know if that's the experience of everybody else, but that's certainly mine.
Yeah, thanks, Nathan. I just wanted to say I work on similar stuff in terms of DevOps, and I actually write security software and deploy it. Most of my time is actually deploying the software, not writing it. So this has been super interesting for me, because I'm trying to catch up with the state of the art in AI and machine learning, and figure out how it applies to the stuff I actually do day to day. So this has been super, super helpful. I noticed you didn't talk about GitHub Copilot, which is kind of the elephant in the room. It writes your code for you. I haven't tried it yet.
That's true, and probably should have. That's an oversight on my end. That I should have mentioned that one as well, because it gets a lot closer to that joke that I had of using the technology to replace replace us. Have you used it at all? And if you have, I'd love to hear more about your experience.
Yeah, I haven't used it myself. I've just seen demos on Twitter that look unbelievable. They look like a human being writing code.
Yeah.
So, yeah. Anyway, we'll have to sync up more after this though, because I do work on similar stuff, and I'm fascinated by how we can apply AI to software development. There's a lot going on, but I don't even understand 1% of it. So,
Yeah.
but thanks for this presentation. It was really helpful. You gave me
Thank
a
you
lot of
very
ideas.
much.
So, and I love your positivity too, because honestly,
Thank
most
you.
of the developers I talk to are kind of grouchy about all these new developments. It's really good to to see someone who's enthusiastic about all this stuff. So,
Thank you.
all right. Yeah, we'll have to keep in touch.
Appreciate it. Yeah, please do. And thanks for joining and watching.
And I know Pejman's working on similar
Hey,
stuff.
Daniel.
So.
Yeah.
Yeah.
I just wanted to say thank you, Nathan, for the talk. Yeah. Thanks for presenting.
Thank you.
Any more questions, comments? Going once.
All right.
Cool. Well, Nathan, I want to say thank you so much for giving us your time this evening. Interesting talk, and like Nathan said at the beginning of his presentation, please, you know, contact him if you want to continue the discussion, and let's keep the conversation going.
Yeah.
Awesome.
Right. Keep in touch, everyone.
All right.
Thank
awesome.
you.
Good night.
Thank you.
Night.
Mhm.